Hi viewers, how are you all? Hope all are safe at home. Okay, in the previous class we have discussed regarding in the part 4 of electric current we have discussed with Kirchhoff's laws, two laws, junction law and voltage law, and in this session we are going to learn about the electrical energy and electric power. Electrical energy and electric power. Then Violet, this is Santhosh Kumar. Welcome to my channel, Sims Academy. Okay, let us get into electric work done. From where we have to bring that work? Okay, let us move back to the concept of electric potential or electric potential difference. We did mention there, we defined the electric potential as the work done in bringing a unit charge from infinity to a point in an electric field. The work done in bringing a charge, a unit charge. Work done we mentioned there, V equals to W by Q, where Q indicates I into T, as we have mentioned the electric current as the rate of flow of charge or the charge flowing per second. Okay, Q equals to IT or V equal or else now we have to find the value of W. W equals to V into Q or W equals to V into Q is nothing but I into T. This is the electric work done. On what? On the charge. Electric work done on the charge. Already we know the units for work are joules. If we consider all in terms of SI system. Now, what do you mean by electrical energy consumed by an electric appliance? The electrical, how much is the work done? That is the same energy consumed by the electrical appliance. Hence, we say the electrical energy as the same VIT. Okay, we even define the electrical energy in some other way also. Okay, let us move on to electric power. Generally, we define the power as the rate of doing work. Power as the rate of doing work. What do you mean by rate then? Cost or price of some item? No. In physics, rate indicates per second or per unit time. Here, the rate of doing work is called as electric power. Okay, let us derive its formula here. P equals to W, just now we have got it as VIT by T. TT gets cancelled. Finally, we obtain the formula of electric power as V into I. What is V? V is nothing but voltage. I, current. The product of both voltage and current gives us the electric power. Electric power. And as we know in case of SI system, the power is measured in terms of watts. The power is measured in terms of watts. If much is the amount of power, higher units of power in case of electrical current, we can mention it as kilowatts. Okay, now we discussed power is nothing but W by T or W equals to power into time. What is work done? How do we do the work? We do by using this electrical energy. Hence, electrical energy equals to power into time. Now, what are the units for electrical energy? Here, we can mention it as watt second or watt hour. In higher units, we mention it as kilowatt hour. Got it? This is about the electrical energy, electric current. If you observe carefully here, electric power is the product of voltage and current. Voltage in our domestic purpose, if we are discussing regarding our domestic purpose, the voltage remains constant. As we have the alternating current over here, the voltage always remains constant. It would be around 220 volts to, in AC or domestic purpose, voltage remains constant. Let us suppose it is 230 volts. If voltage remains constant, then how much is the current that is consumed? How much is the current that is consumed by the given electrical appliance gives the electric power. We get the power bill, right? How much is the power? We can say, suppose in our generally in our home, basically mothers or fathers, they say it consumes much amount of electrical energy. They don't use these words. It consumes much amount of current. How come we say that? Because we have some appliances, those observe a lot of electrical energy. In the sense, a lot of electric current is being used up those particular electrical appliances like our air conditioners, refrigerators, yes, and iron boxes, heating elements especially. We have heaters, water heaters, geysers. All these are the heating elements of electric current. They consume much amount of electric current. In the sense, much amount of electrical energy. Yes, the electric power that is consumed by the given electrical appliance. The electric power consumed by the given electrical appliance, we call it as wattage. What it is? Wattage. Wattage is nothing but how much is the power. Suppose we have a tube light. It has a wattage of around 40 watts, and a ceiling fan, I'm writing the approximate values, around 60 watts. Refrigerators, around 100 watts, depending upon the star rating. More the number of stars, less is its wattage. Less the number of stars, more is the wattage. In the sense, much amount of electric power is being consumed by the given electrical appliance. Much amount of electric power in the sense, much amount of electric current is being utilized by the given electric appliance. Yes, by using these wattages, we can even calculate the power bills, electric power bills. How do we calculate generally? Suppose I have only a room, a single room in which only one tube light and one fan. A tube light and a fan per day I use both of them for 4 hours. Let us say. Combinedly how much is this? 100 watts for 4 hours. That means per day how much is electrical energy consumed? 100 into 4, 400 watt hours of electrical energy is consumed. Then for per month, 400 into 30, it is 12,000 watt hours. It is 12,000 watt hours. If I convert that into kilowatt, 12,000 watt hours by 1000 give me the kilowatt hour. That means if I use a tube light and a fan 4 hours a day, then how many kilowatt hours of electrical energy is being utilized? 12 kilowatt hours of electrical energy is being utilized. What does that kilowatt hour represent? That kilowatt hour represent our units. In our daily life, we say the number of units in our electricity bill. Those units are nothing but these kilowatt hours. How many units are being consumed by both tube light and fan here? Those are 12 units. 12 units in the sense, let us suppose each unit it costs around 4 rupees approximately. Then 12 into 4, it is 48 rupees is the electricity bill we have to pay for this room. If I have only one tube light and one fan. What if we have more number of appliances? Obviously, the electric power consumed by them increases. Whenever the wattage of those appliances is more, they consume much amount of electrical energy, electric power, much amount of electric current. As I told you, more current, more power. More power, the number of units increase. What are these units? These units are nothing but the unit for electrical energy. Hence, we have to conserve our electrical energy. And even you can come across the wattages of so many electrical appliances. You can Google them, and you can even prepare your own prepare the electricity bill of your home directly without any hesitation. But the value whatever you get, it is very nearer. It is precise to the original electricity bill. Got it? I hope everybody you have enjoyed watching this video, and this completes the chapter of electric current. And let us get on to the next chapter. I'll let you know. And until then, this is Santhosh Kumar from Sims Academy signing off. Bye.